Hello, it's Technology Blows, the only technology podcast for people who hate technology. I'm your host, Dan Slimman, and my guest today is the wonderful CJ Horton, an old friend of mine and software engineer, and just all-around very enjoyable person to spend an hour with. CJ, are you stoked to talk about Jira for an hour and a half?
I love making fun of Jira. It's basically one of my favorite hobbies, so as weird as it may sound, yes, I am excited to talk about Jira for an hour and a half.
I knew you would be. I was like, who do I want to talk to Jira about? I know, CJ. They always have something negative to say about Jira, and that's why I called you.
It's an important skill.
Right. It keeps us surviving in this hell world.
Exactly. You've gotta unite around something to hate, and for any software developer that uses Jira, that is Jira.
There are worse things you could unite around hating, if you ask me. What have you been up to this week in the good old Pacific Northwest?
The rain has started in this fall, so I have been exploiting it to the fullest by drinking tea and reading a Becky Chambers novel. It's great.
I saw David Byrne on Tuesday at the Oakdale Theater in Wallingford, Connecticut, and holy shit, what a show.
Ooh, that sounds awesome.
They had 14 people on stage the whole time, matching blue jumpsuits on everybody, full choreography for every song. They had 6 dedicated dancers. I was blown away. I thought it was one of the best rock shows I've ever seen. There was one moment where they displayed different bumper sticker messages on the projectors behind the band. It was David Byrne loves symbols and signs and stuff. So there were a bunch of these logos up on the screen. One of them toward the end was a big "Make America Gay Again" with rainbow letters for gay. And next to that, there was a No Kings logo, but a Burger King version of the No Kings logo. As you'd expect, this played very well with the audience of a David Byrne show in Connecticut. But there was this guy in front of me, blonde, curly hair, strong jawline. He was kind of hot, actually. But when these liberal messages started showing up, he hunched down. He stuck out a big thumbs down, and he was clearly very. I don't think looking at this guy, it looked like he definitely played high school lacrosse, and his name was Tristan, and I'm pretty sure he was not coming at this from the left.
And it had a David Byrne show somehow.
Right. Oh, David Byrne, stop being all political. Yeah, it was really funny. So he for the next few songs, he was all pissy, and hunched down. He would just say little things to his girlfriend and frown and cross his arms. But eventually I saw him. I was sitting behind him, so I could see him start to bob his head to one of the songs because the beat was so catchy. And then I saw the moment where he realized he was doing that and brought it back down, controlled it and turned it into a head shake. This song is pretty catchy. No, David Byrne.
Get behind me, Satan.
Yeah, exactly. You got into it by the end, though. You can't not.
Yeah, that's hard to resist.
Yes. So that was my week. Pretty good. All right. Without further ado, we've been stalling for too long. Let's dive into the always exhausting and sometimes downright upsetting world of Jira.
Let's do it.
Yeah, let's do it. We can do this. We know about software. So as some listeners might know, Jira is a software issue tracker. So it's a web application used mostly in the software industry for planning and tracking work. According to Atlassian, the company that makes Jira, it's used worldwide by more than 300,000 companies. Things that need to get done are represented in Jira by issues. And an issue can be assigned to a person, it can have a due date, it can be part of a larger collection of issues, and so on. That's what Jira is, essentially.
Fun fact, I recently got a notification in Jira that things are no longer called issues, they're called work items.
Finally,
the Jira
finally
change
they fixed
that you've
it.
been waiting for, right?
Yeah, all right. But thanks for coming on, CJ. But you can go. You can go now. I don't have anything bad to say about Jira anymore. It's work items now.
Work items. It's all work items all the way down.
It always, always was. So Jira isn't just one thing. It doesn't just come from one place. So I want to talk about two of what I would call the ancestors of Jira, by which I mean prior techniques that served some of the same needs as Jira serves or Jira was invented to try to serve. The first of those ancestors that I want to talk about is called production planning. So production planning is a subfield of scientific management, which was essentially the science of labor exploitation, how to maximize the ratio of profit to wages paid. I mean, this is how these guys talk about it. It's not just me editorializing. Maybe don't use the phrase labor exploitation, but this is what scientific management.
But
yeah. So you take scientific management, you apply it to the question of in a factory what to produce, in what order to produce it. That's production planning. Now, up to about the 1890s, you didn't really need a science for that. You just had a factory, you had foremen who were in charge of who started the order, what order, when, and at most you had a posted list saying, okay, this job's going to start on this date and it's due on this date, and that's all you really needed. It worked pretty good when all you need to do is produce a small variety of finished products at the end of the
artisanal factory management. Hand rolled,
very, very artisanal. Yes. Yeah. You hire somebody to make chairs and they just tell everybody what to do and chairs come out, right?
See, okay, go.
Yes. Because it's not that complex, right? You just keep working and you finish your orders and you're done and everybody can go to the bar. Then in 1886, though, a guy named Frank Julian Sprague invents the first practical electric motor, which basically means, the first electric motor that didn't shoot sparks everywhere, which is important in a factory setting.
Seems like an important feature of any kind of machinery, really.
Yeah. It's 1886. Everybody's clothing is made of paper and covered in oil, so
everything's built of wood. Yeah.
So electric motor that doesn't shoot sparks everywhere is pretty good. And it's also safer because if your factory is powered by a water mill, a lot of factories are powered by water mills, you have to keep all your powered machines, anything that needs power, you have to keep it over on the side of the factory where the waterfall is. And so you can kind of transfer power from there to somewhere else, but you need like chains and ropes and gears and shit that are all now strung throughout the factory. And all those chains and ropes and snapping around and all those gears grinding, you lose a lot of power that way. And also you lose a lot of limbs that way. So with the electric motor, you have wires and they can carry power up to anywhere you want in the factory without anybody getting their leg caught in a gear. So it's pretty good stuff.
That's a whole different technological evolution as factories that don't kill people very often.
Yeah, I think that's great. I think factories shouldn't kill people. So
this is a bold stance, Dan.
Yeah, go ahead and cancel me. So now that everything was spread out and you could do lots of work all at the same time, you could make not just a small number of products from a given factory. So that in turn created opportunities for economies of scale. So for example, say you have an order for mouse traps, an order for a bunch of padlocks, and an order for coffee grinders. And all three products happen to call for the same kind of spring, which your factory also makes. So rather than make a batch of springs for the mouse traps, another batch of springs for the padlocks, and a third batch of springs for the coffee grinders, it's cheaper to just make one big batch of springs and split them up, because then you only have to set up the spring making equipment once instead of 3 times, so it's cheaper. Provided that you can time it so that each of those 3 orders can proceed more or less immediately as soon as they get their springs, right? Because if you plan it wrong and the timing doesn't work out, then you end up with a bunch of useless springs sitting around burning a hole in your pocket.
You just have a lot of springs that you have to store somewhere.
Yeah, what are you going to do with all these springs?
Someone rid me of these troublesome springs.
Yeah, I can't sell these springs. What am I going to do? Go to door, beg all my high school friends to subscribe to my Spring of the Month service?
It's the same spring over and over for 12 months.
Yeah, no, you're going to love it. So if you can execute this efficient, like just-in-time, large batch production scheduling trick, it can save you a lot of money as a factory owner, but it's not easy. So companies started to look for more sophisticated ways to do this production scheduling because it's tricky. And they invented the Gantt chart. Have you ever had to use a Gantt chart?
I know the term, but only in the most general sense. I've mostly heard it mentioned like in an insulting way.
Yeah, maybe you were talking to me. I don't have any problem in principle with Gantt charts, but they're not appropriate for software. The Gantt chart was invented by Henry Lawrence Gantt in the 1910s, and he was a scientific management guy. And when I say Gantt chart, I'm referring to a particular kind of chart, but Henry Gantt didn't just invent one kind of chart. This guy, come on.
He's a chart maniac.
This guy, he was a chart maniac. He came up with charts like Thomas Edison came up with ways to murder elephants. He was just an incredibly prolific chart comer up with her. He might have had a problem. Like if you were out to dinner with Henry Gantt, he would just keep disappearing to the bathroom and coming back with ink on his fingertips and stacks of drafting paper sticking out from under his jacket.
He sounds like the kind of person that would like come into the dinner with like a chart of the optimal selections at each course, you know.
Oh no, she didn't like her pork chops. I'm gonna have to redraw my whole chart. Everybody stop eating. Yeah, I have to redraw this chart.
I have to replan this entire meal.
Yeah, the Gantt chart is just like a very information-rich representation of the most efficient ways to fill a sequence of orders. It also lets you track the progress of work against the plan that you've written. So a Gantt chart can tell you if you're behind schedule and you need to go out and give everybody a pep talk and get them to work harder, or maybe buy them some pizzas. Making Gantt charts is itself expensive. You got to have people draw the whole chart on paper, redraw sections of it every time the plan changes. And you got to do all this detailed record keeping, asking everybody all the time, how much work did you get done? How much work do you still have left to do? What's the hourly rate at which this work is getting done? And to feed that data back into the charting process, which involves a whole bunch of tables and notebooks and logbooks and shit.
Of course, nobody has invented computers yet, so...
Yes, and when they invent computers, this will all be solved, and we'll just have a perfectly efficient production forever.
Exactly.
They did add computers in the 60s to it, but like it pays off if the plans are accurate, and it's a waste of money if you're tracking work where you can't make accurate plans.
And you also somehow need 100% accurate data coming in to constantly update the plan.
Right. So does it make sense to apply this kind of in-depth planning scheme to engineering, to software engineering? What do you think, CJ? Is software engineering a world of highly predictable workloads where something that looks like it's going to take 4 hours always takes 4 hours?
I think it's predictable in the opposite, like in a sort of like monkey's paw kind of way, in the sense that like if you predict something is going to take 4 hours, it is almost certainly not going to take 4 hours. It may take less than 4 hours on the rare occasion. It may take more than 4 hours. It almost certainly will not take exactly 4 hours.
That's too bad. That's a shame because of where this episode is going. So like you can make a detailed plan for a software development effort. Of course you can make a plan, but as soon as one of your engineers runs into a little hiccup, the plan instantly becomes fantasy literature, right?
Exactly. Something we all know well.
Something we all know well. So in software engineering, instead of centralized high context planning leading to lower costs, as it does in manufacturing, it leads to higher costs because you have to keep updating this useless fucking plan. I read an article for research called Towards Project Management 2.0 by Raymond E. Levitt, published in the Engineering Project Organization Journal in 2011. The author recounts that he was working on building a nuclear power plant, and they had just installed thousands of pipe supports. You know, these little struts that hold pipes in a particular position. There are a lot of pipes in a nuclear power plant, so they had just installed thousands of these pipe supports in the last week. And then the Nuclear Regulatory Commission changed its rules one day in such a way that all those pipe supports would need to come out and get reinstalled. Well, what can you do, right? It's the Nuclear Regulatory Commission. You can't just be like, come on.
Give us a break,
come
man.
On. Oh. Look, they're fine. Look at it. Look at the pipes.
It'll be okay.
Pipes aren't going anywhere.
And if the reactor falls over, it's no big deal, right?
These aren't people who give you a lot of leeway. So this guy, he was in the meeting about what to do about the change in regulations, and he says, quote, "The professional planners in the room stated that they needed a week to update the plan. So the removal of old pipe supports and construction of the new ones should be halted until they could develop a new baseline plan."
Oh man.
And does this feels familiar
I know,
though?
it feels
right?
eerily like I have been in this room. I've heard this conversation play out.
Yes.
We've just got to redesign our process, and then we'll be able to do the thing.
Yeah. Something unexpected happens. I guess that means we didn't collect enough data. Okay, we need to double the amount of data we're collecting so that this will never happen again to our precious plan.
We'll not talk about what types of data, just data. We just need data, any kind of data. That's a whole different conversation, though.
Just shoving in the computer. Out comes profit. Okay, so production scheduling was the first ancestor of Jira I want to talk about. The other one I want to talk about is called bug tracking. So in order to track bugs, which are defects in software, basically anything where you notice the software's not doing what you wanted it to do.
Rare cases, actual insects.
Right. Yeah. Sometimes actual insects in the machine. I wish there were more bugs that I had to deal with at work these days that are just like, oh, somebody let a cricket into the Amazon data center and it just got in the fan in one of our servers. That's easy.
I assume that's a real thing that happens occasionally in data centers. Like, just nature injects itself unexpectedly into the data center somehow. I've never worked in a data center, so I can't confirm.
It would have to. They're anti-entropy machines, right? Data centers, they're just a big anti-entropy building, and entropy always wins.
It's true.
I know. I have to say, when I used to work in data centers, I never got a mosquito bite while I was working.
Well, small perks of the job.
Yeah. It was one of the positive things I can say about that line of work. So if you want to track bugs, you have to have a concept of a bug. And all technology has defects, but the concept of a discrete software bug that you could track as a bug didn't emerge until pretty late in the game. First we had to have the idea of a piece of software that exists independently of the computer as a distinct vessel of value. Because for a long time, there was just the computer and programs, which were work for the computer to do. You bring your program to the computer, punch it in, or put a punch card into the computer, and the computer would run your program. And you'd know all the inputs and outputs of the program. You wrote all the inputs, and you could read all the outputs, so you could spot bugs pretty easily. If you just get output that doesn't make sense, and generally you would just debug the program and run it again.
You would get no output because something broke on
right. You get no output, or the machine would be down and somebody would have to spend all night fixing it. And sorry, you don't get to run your computer program again tonight.
Also, these were also like relatively small by modern standard systems, right? They weren't that complicated. You didn't have
exactly.
You didn't have 100 people working on them.
Exactly, or 1,000 people, or software dependencies that represent the work of hundreds of thousands of people like we have now.
Yeah.
So throughout so in the 1970s and 80s, you're right. The complexity of a bug in the 50s, 60s was capped by the total amount of labor hours that people had put into software. Total. And that was a small number in the 60s. And then it started blowing up in the 70s and 80s. Programs got more and more complex because more people were working on them. Teams of people were writing software. So inevitably, bugs would be discovered in this new complex software because all software has bugs. But at least some of the bugs that were discovered were complex or confusing enough that they couldn't be solved right away when they were discovered, or not important enough to bother solving right away. But you didn't want to lose the information about them, so you had to track the bugs. You had to store the knowledge somewhere. Initially, and it was hard to figure out what the history on this was because nobody really wrote about it. As far as very few people have written about how bugs were tracked before bespoke software that tracks bugs. Right. But you had to track bugs. And it seems to be mostly that they used like spreadsheets per department. Each team would have their own bug tracking system. It'd have a spreadsheet or just a piece of paper where their bugs were written, and you'd pass it around.
So we're kind of back to the hand-rolled, artisanally crafted method of work tracking.
Yeah. But in 1992, we get the first purpose-built software for tracking bugs. And that product is called GNATS. GNATS, all caps.
That's quite an acronym.
It's one of these recursive acronyms that are so common among computer nerds who are too clever for their own good. It stands for NATS, a tracking system. And if you're wondering where the N comes from, both the G and the N of the word NATS are capitalized.
Is this a GNU era acronym?
Yes, it's
okay.
it's a GNU thing, yes. How do you feel about this shit, CJ, the recursive acronyms?
I feel like there's this thing software developers do where we like optimize communication for each other. And this feels like very much one of those things where it's like optimized for developers talking to other developers, and anybody outside of that loop is just gonna be like totally at sea. But
Yeah, you're writing it this way because you're gonna send it to your friend in the other cubicle, and he's gonna look at it and be like,
right, because your friend is gonna laugh, and
right.
it's the the entire
What else could matter?
ethos, exactly. And you're in the business of making fun of people who don't write software, so
Yeah. Oh, you don't get it. You don't get it because it's a recursive acronym. No, I don't get it because it's stupid.
it doesn't make sense. I still don't understand where the G comes from.
Yeah. They're kind of fun, but they're always kind of an anticlimax. You look up what it actually means, and you're like, oh, okay.
Yeah, I'm sympathetic because, like, if one of my dumb work in jokes somehow became like outlived its usefulness and became like the name of some kind of industry standard tracking software, like I think I would also be ashamed of that outcome. But like I can't imagine a dumb work joke be having that kind of lasting power.
Yeah, I've named some things some pretty dumb things, but luckily nobody ever uses my software after I write it because it's not that good. And you know how modern software is web-based, CJ?
I do.
Are you
Oh,
familiar with this web-based software?
tell me more.
NATS. Well, I'll tell you what NATS wasn't. It wasn't web-based. It was email-based.
Oh man,
So
that's great.
different. You would email the bugs to your. Be like, I have a bug. You'd email NATS at your work domain or whatever, and put the bug information, and it would store it in a database. Different front ends were built for it. Like there was an ncurses front end and a web front end built for it eventually. But they were all kind of janky, and I think that's because they were just email clients under the hood.
Yeah, I mean, what else could they? Because what I'm not familiar enough with the SMTP spec to know, like, do you have anything more than a subject and a body to go off of?
I mean, you got headers.
Yeah, there's some headers, but as far as like rich metadata,
There's no metadata. That was why OpenBSD, which is a large open source operating system, was using NATS for bug tracking for a long time. And it had no, if you had a bug in Make, if you had a bug in the software utility Make, how do you find that bug? Right? You're just searching for the word make, then you're going to find every ticket in the system. So throughout the 1990s and early 2000s, a lot more bug tracking software products emerged. Tell me if you've used any of these. RT, which stood for Request Tracker.
oh,
Fog bugs.
nope,
Mantis.
nope.
We
A lot
used
of
Mantis
insect
in my
themes.
first job. Right, because there's like bugs that eat other bugs or things that eat bugs.
Yeah, Mantis is actually a pretty great name for a bug tracker, I have to say.
Mantis is good, except it had no API. I had to write like a custom plugin that would be an API for it because I needed it to be an API.
Oof. Oh. Man, it's hard to imagine software that does not have an API in this day and age.
Mm-hmm. That was all the rage, not having an API in the late 1990s.
You gotta click on things.
I'm going to share my screen for a second. And one bug tracker I want to touch on briefly is Bugzilla. Bugzilla was built by Mozilla, which is a free software community that was formed in 1998 by members of Netscape. And a hugely important thing to note about Bugzilla is that it has this adorable mascot, Buggy.
Pretty adorable.
We've really lost this, haven't we, in software? There used to be cute mascots for things.
Yeah, I really feel like that was I'm sorry that companies don't lean into having cute mascots anymore. Like, I was thinking of like Octocat the other day. Like, I don't remember the last time I've seen like a company with such a good, like, memorable little mascot.
No, we don't do it anymore because I don't know, because it's
We don't have
has a
fun
soul.
anymore.
We don't have fun anymore. You know, back in the 80s, everybody was having lots of fun. Yeah.
We're giving our software incomprehensible names, but on the upside, cute mascots.
Yeah, there used to be cute mascots for things. RIP. Buggy is a cute little bug that looks like sort of a cross between a peanut and a turtle, and he's sort of rolling his eyes. He's cute. I would like to see this guy every time I open a bug tracker instead of whatever the hell the Jira logo is now. It was like the juggling tornado guy for a while. Now it's just like 3 blue arrows. It's fucking soulless.
I genuinely don't know if I can visualize the Jira logo, which is kind of astonishing considering how much time in an average day I spend looking at Jira.
It's just these like 3 arrows pointing up and to the right.
And then sometimes a little like blue diamond thing.
Sometimes the little blue diamond thing.
This is probably why it hasn't stuck in my head.
Right. Anyway, Bugzilla got very popular because, first of all, as we discussed, it had a cute mascot named Buggy. Second of all, it was easy to use. It was web native. It wasn't fucking email native. And also, Bugzilla's search was good. You could put in lots of metadata, like what version of the product the bug was in, what component. You could assign different statuses and stuff like that. So Bugzilla was a very useful tool for a lot of software development teams. And one of those teams was a pair of fresh-faced 22-year-old Australian kids trying to make it big in the world of software with a little startup you may have heard of called Atlassian.
I wonder if this is the first startup that named something Atlas. Bearing the world on its shoulders is such a compelling image for software.
You know, it can't be the first. People have been... it's not a very creative name, right? Like, they explain it. I've listened to a lot of interviews of these guys, and they're always explaining, like, the software came from... is like Atlas holding the world on its shoulders. And I'm always just like, yeah, obviously, like,
everybody knows.
Everybody would think of that.
Everyone has worked on a software project called Atlas that holds the world on its shoulders. And it probably shouldn't.
Jira holds the world on its shoulders, but the world is only as heavy as it is because it's made of Jira.
It also holds the weight of Jira on its shoulders.
Exactly.
Yeah, speaking of recursion, maybe that's what the 3 arrows represent. It's the nested Jira. You've got to have Jira to track your Jiras.
It's Jiras all the way down. I have worked at a place where we were in Jira Cloud, but then we had a in-house Jira to track the bugs in the Jira Cloud.
That's pretty amazing.
So we'll get back to those 2 crazy kids, those two Australian scamps. But first, so we've discussed 2 of the ancestors of Jira, production planning and bug tracking. These are 2 disciplines that study different objects. Production planning works with tasks or groups of tasks, like do this, do that, build this, set up that. Tasks are things that need to be done and will take a certain amount of time. Bug tracking, on the other hand, studies bugs, which are defects in a piece of software. Bugs are pretty different from tasks because, while a bug may imply the possibility of a bug fix, it is not itself a task. It's just information about the software and the way the software works. But Jira, when it arrives like a fallen angel into our world, is going to blur the line between tasks and bugs, because in Jira, tasks and bugs are both represented as issues, or work items now, I guess.
Work items.
You may have different issue types, work item types. What do they call issue types? I'll find out when I use it.
I can't remember now. But yeah, calling a bug a work item is something that immediately bothered me.
Right, because some bugs you're just like not gonna fix. You're not gonna fix. So like you might have different issue types in Jira. You might have a bug issue type that requires certain fields to be populated, and you might have a task issue type or a feature issue type that requires different fields, or the different types might have different statuses that they can be assigned, or like tasks might not have to go through a testing status or whatever. but it's really, really messy. And in practice, in Jira, issues, regardless of what type they are, basically all get treated as tasks, as things that need to get done. They start their life in a to-do state, and they end their life in a done state, right?
Won't do state, my favorite.
Won't do state, yeah. I learned that Bugzilla invented the won't fix issue
Oh, really?
type, which has become so influential.
Oh.
It's just which just means like which kind of only exists if you're doing this to bugs, because you're like you put it into a won't fix state, meaning like we're deciding not to fix this in the time that is allotted, the short time that is allotted to us on Earth.
I guess it's also applicable to like feature requests, which in my world
Yeah,
often
that's
come
true.
in through Jira as well. Like we would like software to have this capability, and somebody else says, actually, no, you will not. We decline your request.
Yeah, but I think a lot of the time when people submit feature requests, they're thinking of it as a bug.
It's true.
We don't have to
It gets
litigate this
really
today, but
blurry. Work items.
it gets really blurry. Yeah, exactly. And so it becomes harder to find information about bugs and harder to figure out what needs to be done. So in other words, Jira doesn't track bugs, at least not in the sense that Gnats or Bugzilla tracks bugs. Jira tracks efforts to fix bugs. And this subtle shift from tracking bugs to tracking issues leads to what I call the infinite backlog, when every defect or potential improvement or routine task is represented as an issue in Jira. The backlog, which is the set of issues that are filed but nobody's working them yet, the backlog can grow to any size. You just keep noticing bugs, you keep having to add issues to the backlog, people keep requesting features, and you keep thinking of improvements you could make. No software engineering team I've ever been on had trouble thinking of potential improvements. So you just add it all to the backlog.
You'll get to it one day. One day, that glorious day when you have time to work on stuff that's actually in the backlog instead of incoming new higher priority things.
Yeah. Yeah, you'll crush that backlog. All you got to do is spend 2 years doing the backlog.
Exactly. I love this, like the backlog. I always feel is like this wildly optimistic construct on most teams, unless you like stay really really on top of like closing things as won't do.
Exactly, but that takes a lot of work.
Yeah. But it's so much easier
right?
just
it
to
takes
say,
no work to add things.
Exactly. And it's so easy to say like, oh, we'll just add it to the backlog. We'll get to it one day.
Yeah. And they just sit there. They just sit there holding value and information hostage in the backlog.
And dividing your attention. Also
and dividing your attention between the things you actually have time to do and the things you are just going to worry about not having time to do.
The things that you would like to do one day, but feel vaguely guilty about not having done.
You're right. It's an optimistic construct, but it makes me feel not optimistic. I think that it makes modern software development. First of all, what's the biggest backlog you've ever been responsible for in a software project?
Oh man, personally responsible?
Your team.
Yeah, I guess it depends on how I define my team. I work across teams a lot, so I tend to kind of think of the size of my backlog as like shared across several, which would easily be like many hundreds of items deep. And that's even with having switched bug tracking software at one point, and so we closed out a lot of stuff. Still, it's just this kind of like
you just keep coming.
Sisyphean. I almost want to flip that question and talk about the smallest backlog I've ever worked on, which is a team that had the ethos of like, we don't keep bugs around for later. Either we fix them now or we close them.
That sounds incredible. Of a backlog where people actually closed things that they weren't going to have time to do. I've never experienced that. I joined a team in 2018 that had a backlog of 4,000 issues.
Wow.
And nobody wants to, because it's just like, you go through them and you're like, we might that's still a good idea.
Yeah. It's so hard to give them up.
It is.
Yeah.
Because it's information. Why would you just delete information?
Well, the thinking behind this particular team's methodology was like, the information is still there. We can reopen things.
Yeah, sure. That's what I tell people when I'm closing issues, because I'm just never going to do them.
Exactly. Most of the time you don't, but...
Yeah. In principle, sure.
Nothing in principle, nothing is being lost. We're just expressing that this is not our immediate priority, so we're gonna close it. That didn't last very very long. Eventually, somebody got mad that we closed the wrong thing and made us stop closing everything. But
Jesus.
oh,
That's depressing.
oh,
It makes it feel so futile to have this infinite backlog, you know? You just come in every Monday and no matter how hard you worked the last week, no matter what kick-ass feature you launched or how many bugs you fixed, there's just always more and you can see that there's always going to be more. You're never going to have a break because there's always more work to pull from the backlog.
yeah, it's incredibly demotivating. Big backlogs are just the Sisyphean effort, especially if you have any kind of like regular triage where you're going in and looking through the bugs, your emotional support bugs. And every week you triage like the same bugs and you're like, "Oh yeah, the last time we talked about this, it hasn't changed because nobody's had time to work on
Yep.
it." It's still here. It's still here though.
It just becomes a stream of generic tasks rather than anything like a thing that needs to be done or a thing that could make something better. It's just a bunch of you're just a processor of tasks.
Yeah.
I find it drains all character from the work and just sort of like soaks everything into a uniform gray slurry of work.
Yeah, I think it also, for me, it kind of it feels it can get very disconnected from like the actual human impact of like because somebody filed this bug because they were trying to use the software and it didn't do what they expected it to do, and so they
Yeah.
filed a bug about it. But the ever growing backlog turns that into not like a collection of human beings who are experiencing a problem that I can help with, and like you said, it turns it into just sort of this like generic collection of tasks.
Yep. Take more tasks. Are you done with tasks? Take more
We
tasks
got more
out.
tasks for you.
Yeah, it's very alienating. And who do we have to thank for this alienating gray sludge? Well, in large part, those two fresh-faced Australian kids from before. So, in 2001, an information technology student sent an email to his University of New South Wales classmates asking if any of them wanted to start a startup after graduation. This student was Mike Cannon Brooks, which can we just take a moment to appreciate how goddamn Australian that name is? Can you think of a more Australian name than Mike Cannon Brooks?
Canon especially seems uniquely Australian, though I know it's not.
Right. I know they have cannons other places. They may not even have that many cannons in Australia, but it just feels really Australian to be named that. Like
No.
Jake Evans Parker or something.
Also, three names. Respect the three names.
Fun fact is because everybody in Australia is a serial killer. That's why they all have three names. But despite having a quintessentially Australian name, Mike wasn't born in Australia. He was born in 1979 in beautiful New Haven, Connecticut, birthplace of the famous New Haven-style pizza and the less famous but equally noteworthy New Haven-style ketamine. But Mike did not remain in the Elm City for long enough to try the pizza or the ketamine. His father, do you want to guess his father's name?
Uh,
It's also Mike.
I was gonna say, is this one of those like trick questions where the reason he has three names is because to distinguish him from Mike Sr.?
Yeah, I think Cannon Brooks is a hyphenated last name, so they're
Oh,
both.
it's not a middle name.
Their names are both Mike Cannon Brooks.
Oh man, wow. Oh.
Father and son Australians. His dad, Mike Cannon Brooks Sr., was a global banking executive. And so, of course, when you're a global banking executive, you move around a lot because otherwise you'd just be a local banking executive, and all you get to do is bankrupt Jimmy Stewart's family on Christmas Eve. If you're a global banking executive, you can bankrupt whole sections of the Taiwanese economy.
Bankrupt at scale. Oh.
Yeah, you could exactly. That's the business model. So when Mike Jr. was 6 months old, the Cannon Brookses moved from Connecticut to Taiwan. And when he was 3, they moved to Hong Kong. And finally, when he was 5, they moved back to Mike Sr.'s native land of Australia. And this was in 1984. But little Mikey didn't get to stay in Australia for long because at age 7, he was sent away to boarding school in the UK. And he stayed in boarding school until age 13, which sounds rough.
That's quite a way to grow up.
7 to 13 in boarding school on the opposite side of the world from your family.
7 seems like a really. I know this is like historically not unusual for kids to go to boarding school that early.
Yeah, but
man,
this is 1984.
so young, man. 7 years
That's
old.
so young.
Oh.
But he became a billionaire, so it can't.
Yeah, it's
Maybe
something.
it worked.
I I was gonna make a joke about like, well, something worked, and then I was like, well, but billionaires shouldn't exist, so maybe this is where
Right.
it all went wrong.
And Jira shouldn't exist.
Yeah. Jira and billionaires, things that should not exist. I also note that it's there's something sort of like grimly funny about 1984 being the turning point. Uh,
Turning point in the life of this guy who creates Jira.
yes.
Yeah, that's true. It is dystopian.
A dystopian piece of software, if there ever was one.
But boarding school wasn't all that bad. Mike says that he was flying so much from Sydney. He had to fly from Sydney to London and back 4 times a year. One Christmas, his parents just handed him a frequent flyer miles catalog and told him to just pick his Christmas present from the frequent flyer miles catalog with all the points he'd racked up.
I was just wondering if frequent flyer miles were a thing in the 80s.
Yeah, they had just come up with it, and and thank God, because that's how Mike Cannon-Brookes got his first computer. So at 13, Mike was ready for high school, so he returned to Sydney to attend a school called the Cranbrook School, which I'm sure you can guess from the name is a very swanky private prep school.
Any school that has the in front of the name, it's fancy. Oh.
Yeah. I went to one. I went to the Bulls school actually, so I'm a little bit pot calling the kettle black here. But the annual tuition for a senior at Cranbrook as of 2024 is 46,497 Australian dollars.
Dang.
Anyway, Mike Cannon-Brookes went on to study information technology at the University of New South Wales. During his time there, I think during his time there, it was kind of unclear in the writing I've seen about it. He and his classmate, not the co-founder of Atlassian, different classmate, built a bookmark management tool together, which they named creatively the Bookmark Box. And they sold the Bookmark Box for what they describe as a small but successful exit. So, good for them.
Man, I always love hearing about software from this era because it's like, a bookmark manager that somebody like in 2025, it's like I can build one of those in a weekend, and I have.
Yeah.
So it's wild to imagine like being able to sell that as a company.
To sell it, right? But it's great because something people need. It's something you made because you want, because you needed it, and
you're solving a problem.
Now all the software is like cab drivers shouldn't be able to survive. Let's turn all the cab drivers into gig workers so we can pay them nothing.
Yeah, we've written all the like low hanging fruit of software, and now we have to solve the problems that our earlier software has caused, which requires more complex software.
Or that turns out never had a software solution in the first place.
Or maybe never should have had a software solution.
Right. That that's what I think. And so in 2001. With one startup behind him and graduation rushing up to meet him, Mike sent an email to his classmates asking if anybody wanted to start a startup. The only classmate who replied to this email was Scott, Farquhar, Farquhar.
That sounds plausible.
Farquhar.
All I'm thinking of is Lord Farquaad from Shrek. It's an unfortunate association for him.
So is Atlassian. Guy Raz, who interviewed them for an NPR, pronounces the name Farquhar, but that can't be right. I looked up a clip of Scott pronouncing his own name himself, but he's Australian, so it just sounds like Farquhar. So I guess we'll just go with Farquhar.
Try to translate to that to an American accent somehow. Oh.
Yeah. I think that's correct. So Scott Farquhar had a much more relatable upbringing, I feel, than Mike Cannon-Brookes. His dad was briefly a computer programmer, but had to quit because of a sleep disorder. And from that point, he worked odd jobs to make ends meet. Sometimes manual labor, sometimes graveyard shifts at gas stations, that sort of thing. Scott's mom was a housewife who occasionally worked, but She would clean houses sometimes, or work at Target or McDonald's. Scott, as a child, wanted, as I think we all do, to play video games. But as you can probably guess, Scott Fackwad did not have enough Sky Miles to buy himself a computer, so he had to get it one the old-fashioned way, begging his parents for years. And
Save up their
finally,
McDonald's money.
yeah, save up their McDonald's money to get a computer so you can play video games, which I
respect
would have done the same
hustle
thing.
from the kid.
Yeah. And his dad, and they did come through. His dad brought him home an old computer that his work was going to toss out. Finally, he brought home a computer for his son. And of course, it wasn't compatible with any of the games Scott wanted to play. So that is, according to Scott, how he learned to work with computers at first. He was trying to get all these video games to run on all this incompatible hardware that his dad brought home from work.
Tale as old as time. What a great origin story.
Did you have any interest? Do you have any childhood interest in computers at all, CJ?
I maybe had a little bit of a weird background here because I grew up in a family where I was not allowed to play video games. So like that seems to be a very common entry point for people to get interested in computers. And so I didn't really I had, used a computer. I was in high school in the AIM era, so I did a lot of instant messaging on AOL Instant Messenger, all that kind of good stuff. I didn't really get into the guts of how computers worked until the MySpace era. So that was my entry point, was customizing.
Oh, sure, because you need to learn HTML and
MySpace profiles.
Yeah, nothing will teach you about the internet like MySpace.
Yeah. And then a little bit later in my 20s, learning that I could automate small bits of my job with Excel, really complicated Excel formulas, going mad with power, building increasingly complicated Excel formulas. Which, there's a debate to be had about whether that is actually programming, but I am on the side of yes, it is.
Yeah, I mean, there's a debate to be had about whether it's programming. There's not a debate to be had about whether it is a faster way than programming to solve a huge class of problems. When I was a kid, I was very familiar with spreadsheets because my parents ran a business out of our home, and they were early adopters of PCs. And I remember one day they were busy in the yard or something, and I was futzing around on the computer. There was no internet yet, so you could let a 6-year-old futz around on a computer unattended, and it was fine.
Oh, the good old days.
There was also nothing to do on the computer. There were no games. It was a business PC.
Right. So the futzing was probably brief at
Yeah.
first.
Well, no, I was pretty fascinated by it. I don't know. I just really, my dad showed me how to make a spreadsheet, and that really clicked with me as a 6-year-old. So I don't know. That's just that kind of guy. I remember I wanted to, I guess there were games because I wanted to change this. We had this terminal-based user interface called Preface for MS-DOS. And I remember I wanted to customize the menu options when it booted up. I think I wanted to add SimCity to the menu because I wanted to play SimCity. But I didn't know how to do that because I was 6. So I was like,
and you can't Google it.
What if I just edit? I know there's this program called Edit that lets me edit things. So why don't I just edit the Preface program in a text editor and find where the menu is and add SimCity to replace it with SimCity. And I completely fucked up the login screen. I think it turned something that was not a new line into a different kind of not a new line, and it was no longer a valid binary. And so now my parents' work computers were all messed up that they had spent a bunch of money on to run their business, which just crash out immediately on boot. And I was frantically trying to figure out how to fix this thing before my parents came back inside. It was very stressful, and I think about it a lot. I process this experience still. I think it might be what made me an SRE.
I was going to say,
panic.
What an origin story for an SRE.
I'm just worried. I'm just always worried now my dad, the CEO, is going to come into the Zoom call and what have you done to my work machine? My dad was very understanding. He ordered a tape backup system after this, and he would just back up the work computers every night, and I could use them in the morning and the evening, and then he would just load a backup before he started working again. It was sweet.
That's actually great because I imagine that gave you more freedom to be able to I'm imagining young Dan as being the kind of person who was not super deterred by the first failure and immediately was like, well, let me try this again until it works.
I was fascinated by failures. Every time it comes up with different random letters and characters on the screen, different colors and stuff. And I wanted to know, like, why did you, I know it failed, but why did it fail that way?
What specifically about this change led to this outcome?
Right. So anyway, it's 2001. Mike sends this email. Scott's down to start a startup. And these two wunderkinds are now poised to take the software industry by storm with the hot new issue tracker called Jira. And like a storm, Jira will gradually spin wider and wider, taking on mass, guided by nothing but its own momentum until it blots out the very sun. And that's what we're going to talk about in part 2. But CJ, how do you think it's going to go? Is Jira going to turn out to be a good product that everyone likes and that ushers in a new era of hyper-effective software development?
I mean, I think it's a fascinating piece of software in a lot of ways, because it's like, you ever have one of those situations where like every step along the way, like you made a choice that makes sense, but somehow you arrive at a really messed up place. I feel like Jira is one of those things where like you describe it and it sounds reasonable. Like, yeah, we have to have a software piece of software for like tracking our work, and
Right.
we're gonna like have these like uniform statuses across the whole company. So like when everybody says in progress or like in triage or whatever, it means the same thing. And so some person high up in the company can theoretically make a dashboard that tells them the status of all these work items without them having to go like track down individual people and ask them about the project. And like all of that, like it sounds so reasonable.
Yeah. Yeah, I
um,
agree. It's like local decisions that are reasonable, but then globally you look around and you realize,
you look up and you're like, wow, something has gone wrong here, and I'm not sure what it was. Like it wasn't just one thing. It was like
right,
the
we made all the right moves in the game.
um we made a lot of decisions that seemed, like reasonable individually, but it has
Yeah.
led to like everything being worse.
That's what I hope. That's a large part of what I hope people will get out of this podcast is that you can present engineers with a series of decisions and they can make all the right decisions locally, and you still end up with something that shouldn't have existed and never needed to exist. Thank you for being a guest on the show, CJ. I look forward to getting into the rest of Jira with you next time.
I learned a lot about Jira origins that I never knew.
Yeah, it was different than I thought it was going to be when I started to research it, and it's no less horrifying. So thank you. This has been Technology Blows. I would be so grateful to you, the listener, if you would drop me a 5-star review in the podcast app. It would mean the world. We also have a Blue Sky for the show, username Tech Blows. So get on in there and follow us on Blue Sky. It's a hoot. We do a lot of shit posting on there. It's not just the episodes. It's you'll like it. Our kick-ass theme music, which you're hearing right now, is by Magic Al. Check out magicalmusic.bandcamp.com. I've been your host, Dan Slimman. Make sure to tune in next week for more Technology Blows.